Markku, ja Markku får superliner. Röntgennimen båten kasi. That's why I have to switch to English, sorry about that. Okay, so I'm Markku from Amazon Web Services, and I would like to talk to you about rethinking the mobile universe. And to have knowledge, we believe that it all starts with great questions. So what are the questions about mobile development? Let's first talk about the mobile universe. What is the mobile universe today? Are the desktop applications and the mobile applications really that different? Let's take a look at that first. So you have an application, and you're thinking, okay, I can provide my app as a desktop app and as a mobile app, so I can reach the full audience. Nice. So how does the application actually get built? You've got your users there on the left. You typically have some kind of presentation layer, and then you have backend services. And you can leverage third-party APIs to have more rich experience and to stand on the shoulders of giants. Don't try to reinvent the wheel. So if you want to, for example, have single sign-on login, if you want to have payment integration, if you want to use a database, if you want to use a storage service, don't code everything yourself. It's just too much. Focus on your applications. That's why on this slide here we have the APIs. APIs to third-party services. So just focus on your core differentiation, your applications, and use APIs. For example, to have storage services, big data analytics services, single sign-on, etc. Okay, you use those services, and then you have your application for your users. So desktop and mobile, same, right? No, not so. Not in the real world. In the real world, there are some certain differences. So, yes, there is some overlap, but it's a little bit smaller. That's why we need to take a look at why would you do desktop development, why would you do mobile development? What are the differences? So desktop is on the left. Definitely the mobile has much greater location awareness. And in many cases, think Foursquare, think even Facebook. You have location integration. If I check into Facebook today, which I've done already from here, Facebook knows that I'm at MOPCON. So it's really cool. But when you have a desktop application, it can be more complex. You can give the user more options without confusing them. So with the desktop interface, it's much easier to have really complicated user interfaces. Mobiles should be kept simple. You can actually do freemium model, so pay as you go or in-app purchases from both desktop and mobile. You have PayPals, etc. You have app stores for the desktop world, like the App Store for OS X. But to be honest, like you know, the mobile payments are still stronger. People are more used to actually purchasing little things from the mobile app stores. But it works for both. And definitely mobile apps are more intimate. Like my good friend Joe in the back there, he likes Foursquare. So he's checking into Foursquare. I'm here at MOPCON. So he gets an intimate, personal experience from his Android phone. I use an iPhone. There are some other differences that define a desktop and define a mobile device. A desktop is defined by many things like pretty much massive bandwidth. You might have fiber connection, at least ADSL at home. You have strong power in the machine, you have a large screen, maybe 29 inch, 27 inch. You typically have a keyboard as the interface. And the mobile, on the other hand, even though they're much smaller, they're really cool things that differentiate mobiles from the desktops. You have all kinds of sensors, motion sensors, GPS, cameras, voice integration, big city, for example. So they are different worlds. One size does not fit all. If you make a desktop application, it's inherently going to look different and use different hardware than your mobile application. If not, if you make the same for both, you are faced with the least common denominator problem. Well, displaying some fonts on the screen, that's not very cool. Okay, we are at MOPCON. So let's talk about mobile. Let's focus now the rest of the talk on mobile, not desktop. So when you do mobile development, maybe the first big question is, should I make a mobile web application, maybe using HTML5, or should I make a native application for that phone or that operating system? That is actually a really common question. This is just one example from a venture capitalist blog. So venture capitalists, VCs, angel investors, they are often approached by developers and startups with questions. What should I do? What actually works? Now take a look at this, if you can see on the screen. If you remember, Facebook started with HTML5, then they said, no, and they made a native application for the phones. What is the reason? Facebook went from HTML5 back to native. Speed. Number one reason is speed. There are some studies that an average usage experience, average time you use a mobile application is just like 1 minute. 1 minute. Speed is deadly. Speed is deadly important for the user experience. The second thing is, if you use a mobile browser, it's abstracted. It's abstracted from the actual hardware of the device. A native application can leverage the strong physical capabilities of the device, like the sensors. Second thing, let's talk about the user interface. This is a nice quote that I like. Don't shrink the desktop. Rethink the mobile user experience. So here's a screenshot from my iPhone from last night. The one on the left is my inbox using the Google mobile web application to Gmail. Actually, it's pretty good. I have to say it's pretty good. Google has done a really good job making a pretty nice user interface as a web browser to their email service. The one on the right is the built-in iOS mail application with iOS 7, the new one. I actually like it. I think it's better because it's more simple. You know, iOS 7 is super simplified. I'm not here advertising iOS 7. My main point is that I think the iOS 7 native app is better in this example because it's more clean and it shows less. And you see on the bottom there, on the iOS, I have used the swipe. I have swiped with my finger one of the mails, and then I get more options. So utilize the multi-touch capabilities. Make native interfaces that are clean and easy to use on the mobile. Even though Google made a really good job with the interface, if you look on the top, first of all, there is a browser URL address bar here. That's just taking space. Then there are some options there to select some other parts of the service. It's too small. You can't even see it, and then my fat fingers can't even touch those very well. There are plenty of other great questions left when you want to make a mobile application. Should I use the App Store? Well, probably yes, if you want to distribute your application and actually make money with the application. You need to basically map a kind of tree of your options. So maybe you are the ball there in the middle. You can choose to make a native desktop application, for example, for OS X, for Windows, for Linux. Then you make that, fine. Or you can make a web interface to your application. That probably reaches a larger audience. You can maybe consider software as a service as the business model. Or you can make a native mobile application. And actually, if you choose to use web, you can still have a couple of choices. You can make a desktop-oriented web application, or you can make a mobile-oriented web application. And since we are here at MOPCON, we need to focus on these two. Either you guys make a native mobile app, or you make a browser-based web mobile. Okay, let's talk about the next thing then. Backend services. You have the app on the phone, obviously. It's not always enough. How do you know what your users are doing? Where do you collect the logs? If you just have the app on your phone, you don't. You distribute the app, Maybe the people use it. How do they use it? You don't know. You want to collect data so that you can use big data to do analytics and you can respond to your users' usage. Secondly, there are many services that don't survive with just the app on the phone. You need databases, you need to keep some state, you need to do data mining, etc. You need a strong back-end infrastructure. Should you buy a server? Or should you maybe just use cloud computing to have as much capacity as you need on the back-end for the servers? Let's take a look. I have an example here from one app called Discover. So this is an app running on the iPad. This is a screen capture from that app itself running on the iPad. So look how pretty it is. With this Discover app, you can discover new apps. And it presents them in a really beautiful interface, in my opinion. So it's an app for discovering more apps. But the point is that it's really, really easy and pretty and nice to use. So that was an example of a really, really nice looking and cool app on the iPad in this case. How did they go live? How did these guys go live? Let's take a look at the benefits of cloud computing. This is a blog from these guys who made that Discover app. First thing to note, they have 1.5 developers. That app was made by 1.5 developers. What do you mean 1.5? There's no half people. One full-time developer and one part-time developer. That's it. That's it. That's the size of the development team. So they realized that they don't exactly have the world's largest operations team. So they wanted the back-end infrastructure that's easy to use, that's scalable, and because they are developers, they wanted the back-end server infrastructure that they can program. They are coders. They want to program the back-end infrastructure. That's why they chose Amazon Web Services Cloud. They use, for example, the load balancer, EC2 instances, relational databases, and a simple storage service. And by leveraging AWS, they were able to have 250,000 downloads of their app in 4 days and survive the load. Because they auto-scaled. Their backend system was able to respond to that viral peak of people really liking the application, and they didn't crash. No HTTP 503 service unavailable. They used the elasticity and the infinite capacity of the cloud to serve their customers. And because the cloud is a programmable data center, these developers, hackers, were able to program the Amazon cloud to respond to their needs. They never needed to touch a server, they never needed to buy a server. Another one. Can you guess? Anybody guess? Which company is this? Which mobile app company has over 100 million users, stores over 150 million photos, terabytes of data, and got the first 1 million users in 12 hours? Any ideas? Yes, exactly. This one, Instagram. 3 developers, 3 engineers managing the backend system for Instagram. One of the biggest mobile apps runs their server infrastructure in Amazon Cloud with 3 people. Angry Birds. Another example, Rovio. Angry Birds, the app is everywhere on all those mobile devices. Angry Birds run their server infrastructure in the Amazon Cloud so that they can go global, and they have the scale of the cloud to support the massive usage of the Angry Birds players. Supercell, another example. Supercell has 2 games, you may know them, Heyday and Clash of Clans. Supercell games run fully on the Amazon Cloud. They have the app on the phone, but all the data, all the databases, all the analytics going global, distributing content, etc. happens in the Amazon cloud. So the cloud helps these companies go global and have a programmable infrastructure, and they don't need to buy servers. They just rent capacity as much as they need. Now, switching gears, let's talk about development then. How do you develop applications so that you can leverage the cloud for your backend systems? We have mobile SDKs. So AWS provides mobile software development kits. How can they help me develop with the Amazon backend services? So front-end app and backend infrastructure in the Amazon cloud. We provide developer tools. So we have SDKs, and we have plugins that you can integrate to your integrated development environments. So in other words, Eclipse plugin, for example. We have command line tools to integrate and work with different services. And we have a new unified command line interface. The command line to rule them all. We used to have different command line interfaces for the different Amazon services. That was a bit painful, yes, we know. That's why now there's one unified command line interface that lets you do really cool things. I personally prefer this. You can't really see, but you can, for example, execute AWS is the command, EC2 is the service, launch instances. AWS S3, get my files, etc. And it's really easy to install. You go to AWSamazon.com, and for example on the Mac, you just pip install AWS CLI. It's all documented on the website here. Besides the command line tools, you need developer environments. You need tools that make your life easier, developing mobile apps that support the cloud. So we have a lot of SDKs. Hope you can see those languages there, but not really. We have SDKs for Android and iOS, Java, .NET, Node.js, Python, PHP, Ruby. We have plugins for Eclipse, Visual Studio. Why did I circle iOS and Android? You are mobile developers. Any idea? I just checked yesterday, the latest IDC analyst report. Can you guess what is the combined market share of Android and iOS for smartphones? Who can guess? Combined market share, iOS and Android. Somebody said 90%, very close. Latest IDC report, 92.5. So if you make a mobile application, I'm guessing you're using either Android or iOS or both, and then you can reach 92.5% of your audience, global audience. We also have an SDK for Windows Phone. Alright, can you show me an example? Yes, I can. Let's start with the demo. Let's take a look. Really hope you can see something here. So, this one is a video. No, you can't. Let's see if it makes any sense running this. No, forget it, moving on. That was a video showing that we have a plugin for Eclipse. So basically what you can do is that you can download Eclipse if you want to use that to develop Java, which is quite common. Here's an example how you can start developing Android applications using the Amazon Mobile SDK. So step 1, install Eclipse. Step 2, install the Android Developer Tools plugin. So this is for Android. So first install the ADT. Then you have to configure the Android plugin. Then you have to download Android SDKs for different Android versions. Then you get the device emulators, for example. With the device emulators, you can run and test your code using an emulated Android phone on your laptop. That's the Android virtual device. So once you set up Eclipse and the kind of, let's say, normal Android development environment on Eclipse, you can download the Amazon Toolkit for Eclipse. And with that, you have libraries to integrate with the different Amazon cloud services. For example, your application can use our DynamoDB NoSQL with unlimited capacity straight from the application. You can use S3 for storage. You can spin up virtual machines, new servers in the backend if you want. So here are a couple of examples. First, you would go to the Android developer website and install the Eclipse plugin. You download the ADT plugin. Wow, you can't see anything. Then it complains that there's no SDK. Yeah, then you download and install the SDK for Android. You select the Android version. Oh, okay. And then you can install the AWS plugins to integrate with different AWS services. What's the point? Why do I need SDKs to integrate with the cloud? They are really helpful. The main point using those SDKs is that you don't have to do everything from scratch. How do you actually integrate with the cloud? The Amazon cloud is a programmable data center, actually multiple. Every service in Amazon, storage, computing, networking, databases, queue services, big data analytics like Hadoop, data warehouses, email services, notification services. The Amazon services are back-end services, infrastructure that you can program. You can spin up new servers in Amazon. You can have storage. You can do Hadoop analytics. Everything with API calls. That's the point. So Amazon gives you a programmable data center infrastructure for all the services. You could write your own code against all the Amazon APIs. You can fully do that. But in many cases, maybe it's just better using a pre-built library that somebody has made, which is reliable and working nice, and you have a higher level interface in your code. You just call the library and execute methods like store an object in S3. So it simplifies your development like this. Well, first of all, using the cloud, you don't have to have servers at all. So when you use the cloud, you can have your development environment on your laptop, and then you can build the code in the cloud if you want. You can build it on your laptop, but as you start to have automated continuous integration, you would actually want to have reliable version control, a continuous integration server, maybe Jenkins, etc. And every time somebody commits code, that should be tested. Automated testing, automated integration. Many people now run, like Supercell, they're building and integration testing in the cloud. So you can use the cloud for reliable storage for your version control, and then for testing. You can do the testing in the cloud. Then, to run your system in production, you need servers, storage, databases, etc. All those are available in the cloud. And the SDKs give you then both high-level and low-level interfaces interfacing with the cloud services. And very importantly, credentials management. Especially if you want to monetize your application, you need to know who your user is. Does he have a license? Now he purchased something. Who is he? Quite important question. So the best practice how to do this architecture would be something like this. You have two choices. You have your mobile device with the app, your app. Maybe you have a front-end service, a service that communicates with the client of the phone. The service could be instances running in the Amazon cloud, so servers in the cloud. They are then communicating with the rest of the cloud, for example, for storage, for databases, for queue services, etc. Or you can do this. You can have your mobile app commanding the cloud directly. So what's the point? You could have, for example, the AWS mobile SDK in use. Then your application can upload pictures straight from the application into the Amazon S3 storage service, for example. So you don't need to have the service in front. But that's up to you, that is up to the service. That is up to the application you're building. So which services are supported by the Amazon SDKs? Mobile SDKs in particular. What Amazon services can you use directly from your phone application? At least these, and we are adding support for more all the time. So if you use the Amazon SDK from your application on the phone, you can spin up servers in the cloud in EC2. You can use load balancers and autoscaling. So you can actually control your backend server infrastructure fully programmatically straight from your app. It's kind of cool. You can use services like our simple queue service, simple notification service, simple email service. Queue service is super important now that you make horizontally scaling cloud-native server applications. You want to have loosely coupled, scalable apps. So using a queue service to decouple between components is really important. What does it mean? In the past, we used to develop monolithic, monstrous applications. Your whole server application was one big block of code and it didn't scale at all. You needed a bigger server to have more capacity. That's not how Netflix is built, for example. Netflix, the service, is 300 separate different services. One of them is storing user information in Cassandra. Another one is a recommendation engine. Another one produces a top 10 list. Another one produces a mobile interface. Another one produces an interface for Samsung TVs, maybe. So Netflix has decomposed their application into separate services. People used to talk about SOAR, service-oriented architecture. Now with the cloud, that's coming back. So the idea is that you take your application architecture, you decompose it into small pieces. Each of these is a service. You make services that implement one thing, communicate with the database, do analytics on the logs, display something on the screen, make a payment, etc. Those are different services. Then the capacity of these services you can scale horizontally using, for example, autoscaling. And the queue services, you can use the queues between these components to have loose coupling. Then if you have a slow service, it doesn't slow down the caller, it doesn't slow down the client. Loosely coupled architectures scale horizontally much bigger and much better. Furthermore, from your mobile applications, you can use our database services. So your apps can directly store data in our DynamoDB, for example. S3 for storage. So how do I integrate these SDKs into my application? Let's take a look at iOS and Android. In iOS, the AWS SDK is a single framework that you can add to your app. In Android, it's a single or service level jar. But it's not bloatware. When you integrate the Amazon Mobile SDK into your application, it only uses the parts you actually use. So it only compiles into the binary, into the deliverable, only those services that you use from the SDK. And in Android, it uses by default ProGuard. You really want to use ProGuard because that makes reverse engineering your application much more difficult and much more secure. So ProGuard on Android removes the unused code. Don't have it there. That would increase your attack surface of your application. ProGuard is also obscuring names so that it's not so easy to guess my user password field, for example. And you get a smaller, harder to reverse engineer application. Never mind, just use it. So the point of this slide is just use ProGuard. For mobile developers, we have a blog. It's called mobile.awsblog.com. That's a really great place because the AWS engineering team for mobile is putting their tips and tricks, new service announcements, best practices, documentation, SDKs, everything. That's a great place to start. All right. This is a developer conference. How about having some code? Okay, let's jump into some code. So here's an example using the Amazon SDK for integrating with S3. Amazon S3 is our simple storage service. Simple storage service was one of the first services we launched. It's currently storing over 2 trillion files. The whole Dropbox runs on top of S3. If you use Dropbox and you store a file on Dropbox, it's actually stored in S3. The whole of Spotify, all the songs in Spotify are in S3. When NASA downloads pictures from Mars, they put it in S3. Then they calculate the images and manipulate them for displaying using the Amazon cloud. Okay, so S3 is a really nice place to store objects. It's unlimited capacity and it provides 11 nines of durability. What the heck is 11 nines of durability? I used to work in the telco field, carrier grade applications, very, very high quality. Telco requirement is 5 nines. 5 nines of availability. Amazon S3 has 11 nines of durability. It means if you store 1 million files in S3, maybe in 100,000 years you lose one file. So when you store an object in S3, it's automatically replicated across multiple devices in multiple different data centers. And S3 has protection against bit rot. So if the bits stored on those devices start rotting and decaying, S3 notices that because of checksums and other copies, and it fixes the problem. Those are some of the ways S3 achieves 11 nines of durability. Long story short, nice place to keep files. How do you integrate with it? So with the SDK, you can do this. Amazon S3 client, so you initialize a new client object called S3. Using the library, you can just call new Amazon S3 client and give it your access key and your secret key. More about the key management later. So every time you integrate with the cloud, you need to have a cloud account. Then you have an access key and a secret key. So you create a new client for integrating with S3. Then you can call a method. So you have an object S3, and you can call a method create bucket. With create bucket command, you can basically make a folder in S3. We call it a bucket. In this bucket, you can store objects, files. So you can create a bucket. For example, your application can keep the pictures that people are uploading in this bucket. Then you can make a put object request. This is what you would use on your client side. Put object into the S3 storage. Where? Picture bucket name, name of the picture, new Java IO file object, etc. So it's pretty easy to integrate. And then later, you can get the object. So S3 object called data, and the command is S3, which is the service name, get object from which bucket, what picture. How do you know what pictures you have? If you have millions of users uploading pictures into your bucket will have millions times millions, maybe, of pictures. You need to keep track of those. Yeah, you could list the bucket, that would take forever, or quite long. So that's why people use, for example, our DynamoDB. A key value, NoSQL, as a service database with unlimited capacity, consistency. So in DynamoDB, you can store the references to the pictures. So your application is maybe storing the picture in S3. S3 gives you a reference, a pointer to the new picture. You put the pointer in DynamoDB. This user ID, has stored this picture reference linked to S3 into S3, and maybe some metadata for the picture. So you can use DynamoDB, for example, as a place to store reference links. How do you actually integrate them with the services? So the Amazon SDK gives you low-level API access. If you want, you can program directly against all the methods in the services. Or you can use high-level high-level commands, which are easier to use. So for example, to integrate with the DynamoDB database service on iOS, it's directly available in the persistence framework for Code. And in Android, we have a DynamoDB mapper. So in this slide, we have an example. Hope you can see something. Kind of hard to see. Well, what you can see is that with the low-level API integration, you have to write more code. You have more control, yes. But when you use low-level APIs, you have to do more yourself. When you use a high-level command, it's easier. So it's up to you. That's why we provide both high-level and low-level API access from the SDKs. Low-level gives you control, high-level makes your life easier. I'm lazy, I would use the high-level, if it works for me. Alright, let's not forget about security. Let's not forget about credential management. We have a really, really funky service called a token vending machine. What the heck is a token vending machine? Well, first of all, there's a link where you can read more, AWS, Amazon.com, articles, SDKs. When you go to AWS, Amazon.com, you just click for developers, there's a link for developers, then you can find it easily. The point is that you want to identify your users. If everybody is anonymous, you don't monetize on your application. You can't really collect, you can collect some money from anonymous people, but you want to know who your users are, what are their preferences, so you can keep personalized experiences for your users. Identify your users. You also want to provide them maybe some in-app purchases. That's why Supercell is the number one profitable company in the App Store, because they have near real-time analytics on the user experience for all the users, all the time. They collect all the logs, all the data, and they analyze them. They do big data analytics and user experience management very well. So you need to know who your users are. So your users need to be identified. Identification is something that you want to keep personal, private, and secure. So you need credentials like SSH keys and cloud accounts. Those are called credentials, user credentials. Don't store your root account for your cloud in the application. Just don't do it. Very bad idea. You know how easy it is, I know many of you know, how easy it is to reverse engineer a mobile application. Easiest one. I'm the worst hacker in the world. Let's execute strings on an application name. Probably you can see username, password, root, whatever. And there are some tools to reverse engineer the application very easily. Don't store your cloud account in the application, otherwise the whole world has it. You can't really easily have individual revocation. You can't really, if you have the same user credential for all your users, like users, you can't revoke. You either revoke all the users or nobody. So you need to have individual credentials for your users. It's not that easy to do key rotation either, because if you start rotating the key on the server side, your applications will disconnect. So you need individual security tokens. You need individual credentials per user. That's why we have a service called Token Vending Machine. It's part of our identity and access management. The point is that using the token vending machine, you can give your users temporary credentials for using your application securely. And the service does not store any information about your users. So take a look at token vending machine to solve this user credential management problem. That's why we made it. Okay. This all sounds good, but you don't know where to start. Where should you start? You need some help. Well, we have forums for developers. You will get the slides later, so you don't have to write down a long URL. We have the SDKs. for different programming languages, for different development environments. The SDKs have samples. The code samples are maybe the best way to get going. Just choose a code sample that's maybe integrated with your database if you want to use database. Start with that and expand on the sample. Then we have the mobile blog, so it's mobile.awsblog.com. And then of course we have support. And here at MOPCON, please come and join us. Please come and meet us. So we have a booth. It's just outside the door. It's very nicely. The first booth when you exit the door here is the AWS booth. And we have really cool challenges there. So come and talk to us. I have my colleagues here. You can participate in challenges using the cloud, and then you can win some really cool stuff. AWS goodies. Second thing, join the AWS user group. We have a really nice and active AWS user group here in Taiwan. There is the link, Facebook link, Facebook.com groups, AWS UGTW. And then, specifically for MOPCON, there's a bit.ly link there. Bit.ly on the top. AWS MOPCON 2013. There's a feedback form. Please complete the feedback form and you can receive $50 worth of Amazon Cloud credits. You can probably run your first year development testing environment with that. So just go to the bit.ly link and then provide feedback. We love feedback at Amazon. And then you even stand a chance to win a Keynote. So those people who complete the feedback form, they get $50 Amazon Web Services credits. And we have a lucky draw for Kindle Reader. So please do that. Okay. That was my short introduction into rethinking the mobile universe using the Amazon Web Services Cloud. I'm Markku Lepisto. You cannot see, my Twitter handle is my name. It's kind of long and difficult. Thank you very much. I think we have a few minutes for questions. If there are any questions, please.
好，感谢马普的演讲。那在座各位有没有任何问题？如果没有问题的话，我帮苗栗的黄先生问一下。So, we have one question.
Okay.
Can you can you share the experience about the further opportunity in Asia? I mean,
for mobile developers?
Yes.
Yeah, that's a really great question. So, think big, guys. Think big. I know you can make cool applications. So first of all, focus on your application. Think what is the cool app? So focus on your application development. Don't write your own databases. There's a quote from Joe, was it Instagram, about the database? Twitter founder has a famous quote. Nobody cares if you write your own database. Really, that's not why they use Twitter. Dropbox, focus on the essentials. Focus on your application. Outsource the rest. Use, for example, the Amazon Cloud for your server infrastructure, for development, testing, and production. Don't buy servers. Just use them on demand in the cloud. Leverage the higher level cloud services. Don't just use the virtual machines. Use databases as a service, email as a service, Cube as a service, Hadoop as a service. Whatever you need. Don't use just the virtual machines. Use higher level services. Go global with the cloud. So that's my point. You guys are here in Taiwan. A lot of IT is born in Taiwan. You guys are cool, you rock. But don't limit your sales and your user audience only in Taiwan. Using the global presence of the cloud data centers, you can copy and paste your application and go global. You can launch it here, for example, in our Tokyo or Singapore regions and data centers. Copy-paste to US, copy-paste to Europe. When we introduced our European cloud region, Netflix had their system running in a few hours. They just copied the system that they had in the Amazon cloud in the US, pasted it in Europe. few hours later, blink, Netflix was up in Europe. So you can copy paste your application and go global. Good question. Long answer.
Is there any good quick start guide for us to use? Any good quick start guide?
Quick start guide, yes.
Yeah, we found that the material on the websites are pretty complicated. We get lost and pretty easily.
Yes, absolutely. So go to AWS Amazon.com, click on developers, and then you can download. We have, for example, training materials there. We also organize workshops. So one of the best things is that you can join the user group maybe, and then you have other developers and companies, and also Amazon Web Services there. We do hands-on workshops, we do trainings, and then the best way with the cloud is self-service. You can download user guides, you can download getting started guides. So what I have done is that I have downloaded all the Amazon cloud documentation into my Keynote. So that's a really easy way. So go to Amazon, AWS Amazon.com, we have all kind of getting started guides. Good question.
So thanks for your excellent speech. Thank you.